Hi, welcome to Teardown Tuesday. Haven't got around to this one for quite some time. You may remember this bit of old school test equipment porn from a auction score which I got, which I'll link in down below, and it looks pretty harmless enough, but ta-da! Look at that. Oh, it's just beautiful. And what we've got here is an AVO 1962 vintage. Yes, 62. That was even before I was born. Goodness, it must be old. CT446 transistor tester is the model number on this thing. Serial number 806. So yeah, it probably was the 806th one made. In the old dart, of course. Hi to all my Pommy viewers. I don't know what Z4, ZDA, etc. stands for, but anyway, definitely serial number 806, made in, there we go, 1962, and that is definitely the model number that's been confirmed, CT446. There is a Mark II version of this, I believe, but this is the original, and it's just beautiful. Look at all those knobs. And this one is in absolutely superb condition. It looks, you know, like it's had very little use at all. And it's all got the original, look at this, it's got just the rubber bottoms on the thing, nice attention to detail. It's got a carry handle and of course the latches. And considering it comes from 1962, I mean, there's no rust or corrosion on the thing really. Haven't had a look inside yet, but geez, you know, we don't, I expect it to be just as good as the outside. It's just brilliant. And the quality of the knobs on this thing, just, oh, really, you have to, you know, I wish there was Feel-O-Vision. I really do, because this is just stunning. The wire wound pots. Listen to that. Ah, beautiful wire wound pots and just nice big ball bearing switches on the things. Just absolutely beautiful. And the analog meter, awesome. And that's individually, check it out, individually hand numbered. So maybe they hand tested these things. Even the meter has its own serial number. Look at that. Oh. It just reeks of robustness. Look at these carry not only sort of like carry handles, but designed to protect the input and output banana, or input, I think they're both inputs. Anyway, banana plugs here, and it's just fantastic. Looks like this lifts out. I believe this is like the battery compartment for the thing, because, hey, it must have batteries to actually operate. But yeah, it's a transistor tester. It tests transistors, or it's a transistor analyzer, sorry. And this one was supplied by the Australian agents, Electrical Equipment of Australia Limited in Liverpool Street in Sydney. I wonder if they still exist in some way, shape or form. I doubt it. Look at this beta and noise control dial. This actually might have a bit of an issue, because it does go past there and seems to go more than one rotation. So I think, and it does slip occasionally, so there could be potentially something a bit askew with that, but geez, it just feels beautiful, and it's just awesome build quality on this thing. Remarkable. No wonder it's lasted all this time. Now, the only thing you might think's a bit dicky are these input connectors for the transistor itself. Well, they're not designed for transistors to plug directly in. That's why in the top of the case it comes with this test lead. There it is, collector base emitter, and that just plugs in. I think it just, yeah, and then they screw in like that, and that's just beautiful. That is absolutely stunning. And got a cable on it with some dodgy, you know, it was obviously designed for whatever, some sort of thing to plug in. It's got the original, I wonder if they're 1960s vintage, collector base emitter, there you go. So no color coding or anything. I think I might relabel those. I really like this main function switch here. Look at this, it's got big on there. So this is actually, so it's off at the moment, and it's even got on the other side like that as well, so you can see it on this when you've got it down on the bench and you're just looking down at an angle like this, you can actually see it. So they've thought of like thought of everything there. It's just brilliant. So that's to switch the thing on in meter mode, and then you've got all the different, it can do noise measurement as well, and all sorts of, it's got everything but the kitchen sink. So we've got our input jacks for our NPN and PNP transistors. You have to test them separately, and then you can set the collector voltage here anywhere from 1.5 volts up to 10.5 volts. That's for the internal. Have a look at the batteries when we open the thing up. Or you can switch it through to an external voltage here, 12 volts max or up to 150 volts maximum. So you can test, reasonably high voltage transistors, although they were pretty high voltage for the day anyway. And you've got to remember too, back in the 1960s, I mean, most things were discrete transistors. Well, transistors were just, some things were still valve, and transistors were just coming into vogue, and ICs were extremely limited back then. So transistors were the duck's guts and the new technology coming out, and you needed these analyzers and transistor testers because transistors, they hadn't perfected the fabrication techniques we take for granted these days, and all the huge, fantastic specifications you can get these days. But even when they made this, they still had thousands of different transistors on the market, and and they'd have leakage and problems, and they'd have all sorts of, process technology problems. And it was really important to actually individually test and characterize transistors to make sure that they actually worked. And if they blew, hey, you'd test and replace the transistor, and you'd be able to use something like this to test if a replacement transistor was a suitable substitute for the ones you're doing in terms of beta, leakage, noise, for example, which they got down here, all the big deals. And just like any regular multimeter, this scale is going to be multi-range depending on how you set with the meter switch here. So 0 to 1 milliamp, for example, it might have 100 milliamps on the scale, but that would be 100 microamps full scale, for example. And then you could just dial in that. It does current and also voltage as well over here. So dual use voltage and current mirrored scale, and that looks like a really nice meter. It's not mirror back to eliminate parallax error, but geez, it just looks and feels good quality. I mean, check this out. They've even gone to the effort to put a rubber seal around that meter on there. This is probably designed to be, splash proof or something like that, sort of weather resistant kind of thing. Sort of like a real, kind of like a military grade kind of build on the thing with the case and everything else. So you can see up here that we can set our base current course like this. So we've got dual ranges, 1 to 40 milliamps and 0 to 1 milliamp. So, if you've got a big power transistor with very low gain of like 10, for example, you'd whack it right up here on the 1 to 40 milliamps. And then you've got the course. You could go, it's got 1,000 on there, so that would be like like 40 milliamps full scale base, and then you can with your tongue at the right angle just tweak it with your fine control here. But that's just beautiful, and it's got a meter output. So with HP and LP, I don't know, haven't read the manual in detail. I'll link in the manual down below. Actually, it's got the full operational aspects of this and the schematic as well. I know what you're saying. Enough talk, Dave. We want to see inside this beauty. And by the way, yes, it smells as good as it looks. It really does. That old-fashioned Bakelite smell. I could sniff that all day. It's probably bad for me, cancerous, but geez, I love it. So here we go. Let's lift out this, which is the it's a weird combination of the collector voltage control. I guess they didn't have enough space elsewhere on the box to do it, so they've had to combine it with the, let's have a look. Ta-da! Battery compartment. Check that out. We've got these connectors here. There's one here and one on the other side. Look at that. There's nothing to hold that in. I'm a bit disappointed and surprised by that. Vibration could, shock or vibration could make that fall out. Maybe there is a way to hold it in, but it doesn't look like it. And there's another one over here. So basically that's just taking all the controls there from the top. And Oh, I've released all the smell too, by the way. Fantastic. And you're wondering what these things are? Well, they're the, yep, they just pop off. So these are a U10 battery, which was an ever-ready type, which was quite common back in all AVO and old school test gear like this. I think they're also known as R12, and I obviously don't have many, but look how many we've got. 2, 4, 6, 8, 10, 12, 14 batteries, and yes, they're just like they were like a zinc carbon 1.5 volts per pop. So they've got a big spring in the base of that and a contact down in there, which the contact's look in fantastic condition considering that they're over 50 years old. I mean, geez, you know, like this is just absolutely remarkable, the longevity of this thing. Absolutely stunning. Obviously it's been stored in a really good location, but yeah, these would all be in series. I'm not sure if they're tapping it off elsewhere to get a smaller voltage. I'm not sure, but yeah, I mean, I could probably whack a AA in there or something and see if it goes in and makes contact. And of course, as you'd expect, the quality of the custom ganged switch in there looks like they got dual wipe contacts in there, as you'd expect. Looks very nice. They've got nice ball bearings in there. Look at how they're very nicely tied in, just bundled the wires. They're the wire looms with just this, I think it's just wire, I think. Yeah, that's just like beautifully done. Look at that, it's just gorgeous. Man, somebody really took pride in that. You can also see all the other wiring down in there. Once again, all loomed and cable tied like every centimetre. That's just beautiful. It really is. And this is just the top. Imagine what we're going to see inside. So we'll just whip this top off. It looks like it's all just going to lift out, and it's got, looks like these screws around the outside here, and of course Phillips. That's not going to work. And I expect metal threaded inserts. None of this screw into plastic rubbish. Yep, look at that. Even got washers. Brilliant. All right, I won't bore you. All right, here we go. Let's lift the skirt on this baby. And actually, I might do it this direction. Oh, yep, I got them all. Yep. Yep, look at that. Ta-da! That's clean. Beautiful. And, oh yeah. Oh, that looks really stunning. Look at the looming on that. Beautiful. Our precision resistors here. We'll have a closer look shortly, but that looks in like as new condition. Wow. Now, as you can see, it's all pretty much turret board and point-to-point construction down in here. Like, there is nothing on the back of those, if you're wondering. There is, you know, it's not a printed circuit board. It's just the turrets through there, and then the individual resistors and caps with their leads just wrapped around those turret pins and soldered. But just look at the neatness of the wiring and all that looming. That is just gorgeous. Plessy caps, look at that. Is that, yeah, 500 mic. There we go. Beautiful. Ah, made in the old Dart as well. And made in the old Dart doesn't stop there either. Look at this thing. I believe that's from Mullard. Absolutely fantastic. Classic name. And I believe that looks like an inductor. That looks like a big ass inductor, or maybe a maybe a transformer. Actually, it's got two sides there. Didn't see that one on the other side. So yeah, that's most likely a transformer. I should dig out the schematic and have a look. So if we do have a squiz at the schematic here, link provided down below. Just on that top board there with the battery, yeah, I was right. Look, they've got some, like a couple of cells in series down here, and these ones here all tapped off to that collector voltage range switch that we saw on the front panel. But here we go. Here is the main schematic, and there's not much to it. There's lots of switching pawn around here, of course. How they design these things, it's just, you know, to keep all this in your head and figure out how everything switches. It's just, you know, a lot of the high-end multimeters and things like that, just remarkable. Anyway, so lots of switching around here. No, I should have looked closer. This Mullard thing is an inductor. It's only, look, it's only a single contact one side and single contact the other down in there. So it's not actually the transformer, just the inductor. That's it. So that's definitely not the transformer here for our 1 kilohertz oscillator. The only other inductor I can find over here is this one, all on its lonesome, which goes all the way back over to here, which is presumably our phase splitter. I haven't analysed that or thought about it, but that's the only major component in here, so it's got to be that inductor down there. And these little suckers, which I thought were inductors at first, they're actually wound bobbin resistors. So I think one's 0.3 ohms and one's about 3 ohms. So that's the, yeah, they just didn't have them in these sort of packages like that. These are 1% resistors, I believe, but you know, as your axial ones, as you're familiar with, but to get the low value resistances, well, they had to have them wound on a little bobbin like that. And check this out. Is that some sort of bodge or what? Look, they've got that wire soldered onto there. They're getting a little bit extra resistance out of that, or just flapping around in the breeze. It just seems a bit out of character. And by the way, my humble apologies, these are not capacitors, they're condensers. They didn't call them capacitors back in the day. Bloody condensers. Thank you very much. And check out those handwritten Welwyn resistors that we've seen before on the blog. Oh, just beautiful. All handwritten. And we have ourselves a little coax there. That runs around to the front. That's the oscillator output, by the way. And that runs down to this separate board here. So bingo, I think we have found our oscillator, our transformer, is inside there. Oh man, look at the size of this thing. It's just enormous. Is that a little trimmer on top as well? Wow, that's our 1 kilohertz oscillator. Oh. So if we have a look at our oscillator circuit here, and it's a dead giveaway because there it is screened. So it's all that circuitry is screened, you know, massive high frequency 1 kilohertz sine wave generator. Got to screen the sucker. And you might be going, well, where's the transistors? Didn't see any on the board. Well, ta-da! Lift the top lid on that, and there you go. I mean, this is the control 2, of course. There we go. That's our main beater and noise. There are our transistors. Look at those. Bingo. They're I believe they're either a Mullard OC75 according to the manual and schematic and parts list. Very comprehensive parts list in this thing. It lists every screw and nut and knob and cable tie and everything. It's absolutely incredible. Or a CV2400. I don't know what a CV2400 is, but yeah, they're our transistors, and there's the 3 leads coming out. They've got 2 insulated ones. They've put a insulating sleeve over that. I don't think that's embedded into the actual transistor itself. And then we've got a bare lead coming out, just all point-to-point stuff. So that, there, our 2 transistors down in there. Oh no! Oh, this has just ruined it. Look. We have one leaky Plessy cap. Bloody Plessy caps. Not sure what that one is, but this one's a Plessy, and it's leaking. Ah, bummer. There's the culprit, Plessy, right down in there. Oh, only lasted like 52 years. Dodgy as. Got some more big-ass resistors there by the looks of it on these range switches, and it looks messy, but that, you know, just the way they've tied everything together is really very, very nice, and my hat's off to them. I mean, that is just, you know, really professional looming. It really is. And if you're wondering what these are the push button switches. I'm putting my finger on the bottom there, and you can see the slider go there. The contacts are actually, there's no contacts on this side down here, but the contacts are over on this side. I'll see if I can get a different angle, and yeah, there's still none on that side. Oops. But yeah, these are the beautiful little push button, not little, they're huge, push button switches with the cutouts, the slot cutouts in the board for the wafer contacts and the turret studs. Just beautiful. Yeah, there we go. There's only one contact in that. You can see it right up the back there. There's not many contacts on that particular sucker. There's more on the other one. So there you go, you can see the dual wipes on those. By dual wipe I mean top and bottom. In fact, they're triple wipe. They got 2 contacts on the top surface and 1 contact on the lower surface. And these, you can bet your bottom dollar these contacts are still reliable after 52 years. And there's a mod record plate as well. Nice attention to detail. So if they've modified this thing after it was assembled, or maybe even at the factory, it might, the new products coming out might have a certain mod status. They've improved the design or whatever. It'd be marked on there. But looks like hasn't been touched. They got it right the first time. These people knew what they were doing. And these are our wire wound potentiometers, of course, are dual ganged here, so they've got the top one and the bottom one there, 2 separate ones on the same shaft, and that's just beautiful. You can just feel the precision wire woundness in there. Is that a word? It is now. And there we go, deep down in there. I won't take the whole thing apart, it'd be really messy, but we've got ourselves another transistor down in there. I think there's 5 transistors total, yep, on this entire thing. Ironically, a transistor analyzer needs some transistors. We've got ourselves a germanium point contact diode down there. Absolutely. Bet your bottom dollar it's germanium. Another transistor down in there, and just some more point-to-point stuff on that vertical board in there, and that'd be part of our phase splitter circuit. And you'll notice this ground connecting point down in here. It's just got multiple contacts on there, so they can wire everything down to a central star point. I mean, this thing's only working at 1 kilohertz, but look, star grounded down to the metal case down in here. Brilliant. And by the way, all the cabling going over to our main top transistor input board here, this is all shielded, so you can see the shield down in there going down to our main star grounding point there. And there's the ball bearing on our rotary switch there. That's why it feels so wonderful. Love a good set of balls. And I find the tie down straps on this Plessy capacitor, these capacitors here, absolutely wonderful. They're a rubber. They're designed to pull off. They're really quite hard, but I think it's saying made in England there. Even the rubber tie downs are bloody well made in England. Fantastic. Is there anything in here that's not made in England? And what on earth are they? Look at these little free wired like little flying saucer disc things. I've never seen those before. It's got 1R2E1 on it. It's almost as if it's some sort of plate, low value plate condenser, not capacitor. But 1R2, I don't know. That's very interesting. Let's have a quick measure of that. I'm just using some daggy leads here, so please excuse the crudity of this measurement. And it's definitely not resistor. There we go, 730 odd puff for that sucker. And the other one, yeah, there we go. Yeah, they're little some sort of ceramic type plate condensers. So that is just gorgeous old school. I hope you enjoyed that as much as I did in glorious 50 frames per second, hopefully. This was just, it's just beautiful. really don't make them like this anymore. Just the point-to-point wiring, the tag board construction, classic 1960s, and big ass condensers with the big straps on them, and those weird ass little ceramic or whatever smaller value ones. The hand wound resistors here for the smaller values, just the hand numbered, the hand labeled resistors over here, just beautiful. The oscillator, over 1 kilohertz oscillator in its own case, over shielded case over here. Oh, it's just a thing of beauty and a joy forever. It really is. Oh, and by the way, yes, this is all rubber surround in there, so obviously designed to be like, at least splash proof, something like that. Just fantastic build quality. And it turns out that a AA battery might fit in there, but in terms of getting a contact on the top, it's going to be tricky, and I don't actually have that many AA's to hand here in the lab to power this thing up. So yeah, I want to get this video out today, so unfortunately we're not gonna see it working, but if you want to, I can always do a second video on having a play around with this thing. This was only supposed to be a teardown, but yeah, if you want to see a video, and I can maybe get it up and running, and probably I might have to replace those dried out caps in there as well, so I'm not sure if it'll work off the bat. I mean, this thing is 52 years old after all. And you really had to know what you were doing to actually use one of these things. It is kind of, non-obvious, although you would have been, used to basic transistor tester operation back in the day. But, these days to operate one of these things, like how do you measure the collector emitter leakage current, for example? Well, it turns out you've got to actually swap the pins around and put various ranges and, and do all sorts of things. It's non-obvious, and the leakage current and the gain and things like that. It's just, you read the manual and it's sort of, they say, oh, put this to here and this to here to do, to measure this and this. And it's not obvious how to actually do it all and press this sucker up here and do all sorts of stuff. So it's, it really is it's quite a bit of complex kit that can do lots of different stuff. As I said, it can do the noise. It can measure noise as well. Only does it at the 1 kilohertz, of course, and it does it equivalent to a broadband. So it generates 1 kilohertz and then it just measures broadband. They don't have a filter on the other side to actually get that out. But they say in the manual that, oh yeah, it's near enough. It's, we've done tests and it's good enough. You don't need that filter in there. You don't need expensive filter parts or something like that. But yeah, this can do lots of fantastic stuff. I hope it still works. I really would love to get this puppy up and going, but I mean, it's just for kicks. There's no practical value in having one of these days. So I hope you enjoyed that teardown as much as I did. It's just a gorgeous instrument they don't make anymore. I mean, I don't even have a transistor tester in the lab. I might have some crappy $2 multimeter with some crappy transistor tester in it, but basically I, haven't used a transistor tester for maybe 20 years, I would be guessing. I just haven't had the need to. It's just not something that you typically need to do anymore. I mean, some people might, but gee, it's just, we're back when, in these days, when transistors cost, dollars, tens of dollars each. So, a very, prized components, and not just like 0.001 cents they are these days and just throw away, and you've got, massive fully characterized data sheets and everything like that. And, well, you don't bother salvaging transistors like you did in the old days. But, yeah, there was a time when owning a transistor tester like this was the duck's guts. It really was. So if you want to discuss it, jump on over to the EEVblog forum. Links down below for the manual for this thing that has the schematic and all the info. Highly recommend you take a look at that. And as always, if you like Teardown Tuesday, please give it a big thumbs up. Catch you next time.